Mr. Landlord.
Yeah?
What are you smoking, an army blanket?
Never mind about that. You owe me room rent.
All right, here's $28.
$28, fine. Just a minute. You owe me 13 weeks at $7 a week, and that happens to be a lot more than $28.
Well, that comes to $28.
Did you go to school?
Yes, sir.
Do you mean to say that you can prove that 7 times 13 is 28?
Well, it's gotta be. Certainly it is, because Mr. Rabbit and I, that's $28, that's what you get.
If you can prove it, I'll tell you what I'll do. I will give you the room rent for nothing.
You will?
But if you don't prove it, you owe me double the back rent. Is it a deal?
That's a deal.
Okay.
You happen to have any Crayola on there?
Crayola?
Never mind. I got it.
Oh, you have?
I got the Crayola. The 7 into 28 is gonna come out 13.
That's your way.
That's my way. And it's gotta come out right. Now, first, I put down a 7.
Right.
Now, I'm gonna divide the 7 into 28.
Yeah.
I put a 28 there.
Okay.
Isn't that cute? Now, here we go. 7 into 2. 7 will not go into 2.
It will not.
That's a very big 7 to push into that little bit of 2.
As you say it is.
We ain't gonna hurt that little 2, are we?
Of course you won't.
So we take the 2, open your hand,
Yes.
and I put that 2 right there for safekeeping. But don't drop it and don't lose it. Now, 7 into 8.
Once.
Once, I put the 1 over here, 1 over there. Now, we're gonna carry the 7 because it's very big and it's getting heavy on my shoulders, and I'm gonna drop the 7 under there. Now, 7 from 8
Is 1.
is 1. I put the 1 down there.
Mm-hmm.
Now it comes. Would you mind opening up your palm of your hand, please? I would like to use that 2. Open it up. Give me that 2. You've had it long enough. I'm gonna put that 2 right there. Now, 7 into 21.
3 times.
That's right. 7 into 28. 13. Good enough?
Wait a minute. You have to prove this even better than that. You can prove it very easily by multiplication.
You mean you want me to multiply it?
No, not multiply, multiply. Multiply.
All right. Multiply it.
7 times 13 is prove it. Go ahead.
Now, first, we gotta put down a 13, right?
Right.
There's a 13.
Times 7.
Times 7.
Right.
7 weeks times 13, right? 7 times 3.
21.
21. 7 times 1.
7.
7. 7 and 1.
8.
And 2 to carry. 28.
Now, wait a minute. I'm still not convinced. There's one sure way of proving this. One sure way, and that's by addition.
You want me to addition it up?
I want you to put 13 7 times on that wall and then draw a line and add them up.
You want me to put down 13 7 times?
That's right.
It's got to come out right. There's 1,
1,
2,
2,
3,
3,
4,
4,
5,
5,
6,
6,
7.
Wait a minute. What's the idea of spreading them out like that?
Well, it looks like a flock of seagulls going to hit the electric poles. Now we're going to add them up, right?
All right, go ahead.
Here we go. 3, 6,
Wait a
9.
minute. Let me do the adding this time.
Good. Come out right.
Well,
3, 6, and 9.
Just a minute. I will do the adding. Then there'll be no mistake.
Yeah?
All right? $28 easy. All right? Now,
Go ahead. You have it. Go ahead.
3, 6, 9, 12, 15, 18, 21.
22, 23, 24, 25, 26, 27, 28.
That is one of my favorite videos. Anyways, let's continue with 2.1 discussion. Today's learning objective is to understand set notation and to write sets in 3 different methods. So we're going to go in detail into that. The symbol, let me change the color of my pen into red. This symbol, a backward E, is used to show an object is a member or an element of a set. So for example, let's make set A equals 2, 3, 5, 7, and 11. And since 2 is a member of set A, it can be written as 2 is a member of this set, 2, 3, 5, 7, and 11. So that's one way of writing it. And another way of writing it is simply 2 is a member of set A. Okay? I also want to point out that if, I'll write it on top here, if this backward E means an object is a member of a set, a E with a crossed out like that, that's to negate that. So in this example, for example, I can say number 123 is not a member of set A because it's not included in the 5 elements of set A. Okay, next slide. Here's an example. Understanding set notation. Decide whether each statement is true or false. And when you're asked to do that, be very careful. The very first step is to fully understand what's been given, and the second step is to understand what's being asked. So let's look at A. Oregon is a set of A, where A is the set of states west of Mississippi River. So the first step is to determine whether where is A? A is a set of states, and all these states west of Mississippi River. So I have a map here. West of Mississippi is in yellow. East of Mississippi is in purple. As you can see, Oregon is on the west coast, so therefore Oregon is west of Mississippi, so this statement is true. Okay. B, 27 is a member of 1, 5, 9, 13, and 7. Okay, I'm not sure what the pattern is here, so I need to figure that out. What exactly is this set? So this set is made of numbers 1 to 5, 5 to 9. It looks to me 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17. So it's each number add to 4 becomes the next number. So if I keep going, after 17 I should have 21. 21 plus 4 is 25. 25 plus 4 is 29. And unfortunately, 27 is not a member of this set. So therefore, this one is false. Third one, Z is not a member. This means Z is not a member of VWXYZ. So notice that Z in this set is a member of this set, and therefore this statement is false. It contradicts what was in the what all the elements in the set. Give this a try and see. I will give you the answers in the answer sheet. Okay, next, there are 3 common ways to designate sets. The first one is called the list method. Literally, so far we have seen just the list method. Literally, you just list out every single member of the set. And sometimes we also call this the roster method. And the second method is called the descriptive method. The descriptive method uses a statement, a description, to describe the set. I apologize for my chicken scratch. Again, it's very common sense. It's all about common sense. The list method just lists out every single every single member. The descriptive method gives you a description or a statement. And the third one is a little bit more technical. This third one we need to know is called a set builder, B-U-I-L-D-E-R, notation. Set builder notation. Okay, so let's see. We'll go through each one of them. Here is example in descriptive method. Use the descriptive method to describe the set E containing 2, 4, 6, 8. So let's see. First, we need to understand 2, 4, 6, 8. I noticed that all of them are even numbers. And even number, we often use capital letter E to describe it. So if I have to write it out, I would say the set E is the set of even numbers. But look at that, even numbers, so I would say it's even natural numbers. Remember natural numbers? Natural numbers are the numbers that how baby counts. When babies were first born, somehow they all learn to count from 1, 1, 2, 3, 4, 5. We don't teach babies to count from 0. So those comes more naturally, and we call them natural numbers. Okay? Use the example below. See if you can give a description of this set from -3 to +3. And obviously those are integers. Okay? Those numbers are integers. A third method of designating a set is called, we already said, it's called the set builder, ILDER notation. And this method uses variables. We all know what variables are. A variable is a symbol. Usually it's a letter, right? It's a symbol that can represent different elements of a set. Notice that variables don't, unlike the variables in English, when you spell C-A-T, it's a cat. When you spell D-O-G, it's a dog. Variables, those letters used in math, doesn't have those literal meanings. It just represents an unknown. It's something that can be changed. That's sometimes what's so confusing. In one of those half days, I will show you a very brief video on TED Talk that talks about where did variable x comes from and why do we use x. It actually came from Spain, originally came from Greece via Spain. So there's quite an interesting story there. But again, here I just want you to remember a variable varies. It just means it's an unknown. So set builder uses a variable and braces. Did I spell that right? B-R-A-C-E. And a vertical bar. And a vertical bar like this. That's read as such that. Okay? So a set builder notation uses a variable and then braces and a vertical bar that's read as such that. So what does that look like? And oops, this is a repeat. And another point is I want you to know that usually we use the letter X for the variables, but we really can use any letter. We don't need to repeat this part. In your notebook, you should have example 5. It's asking you to write a set using a set builder notation. And then it's asking you to write down how your answer would be read out loud. So let's look at A. A says the set R contains elements 2, 4, 6. 2, 4, 6 are even numbers, so we can say that we know that they're even numbers first, and they are also even numbers less than 7, right? Because there's only 3 of them. So if we write it, we said set builder notation includes a variable, and then it has braces, and then we use the variable x and say x is such that x is an element of, I would do E for even numbers, and x is less than 7. Notice that I used and. That's really important. That if without the and x is less than 7, my set would include 2, 4, 6, 8, 10, and it goes on and on, all the even numbers. But the x is less than 7 regulates that it has to be less than 7. The largest number is 6. And the way I would read it is the set of all x such that, that's what that bar is, such that x is an even natural number and x is less than 7. I think with that I got my ground covered. Okay, the set of all x, start from here, the set of all x such that x is an even number, right here, and, I should use a different color, and x is less than 7. So that way I get all the conditions covered and I describe the whole set. Next one, the set W contains the elements red, yellow, and blue. So we said the name of the set is W, and then we start with a variable x and a bar, braces, and then we say, all we need to say is x is a primary color. That's all we need to say, right? The set of all x such that x is a primary color. So this is relatively easier compared to the first one. Try these two before you move on, and if you need to pause the video, pause the video. Again, I will upload the answers to these. Let's look at example 6 using different set notations. Designate the set S with elements 32, 33, 34, 35, and go on and on and on. So there are 3 different methods. Roster method is the list method. All we need to do is to list everything. And then this, remember these 3 dots in the back indicates that it goes on and on and never stops. The descriptive method, I would say, I'm not going to write it down, I would say the set S is the set of natural numbers. These are natural numbers that are greater than 31. Okay, notice that when I said greater than 31, so 31 is not included. And if I write out my descriptive method, I pretty much have my set builder notation set up already. So I would say x, and this is natural number, right? So x is a member of the set such that x is a natural number and x is greater than 31 according to my description. So again, this is the set of all x. This set is a set of all x such that, that's the bar, x is a natural number and x is less than 31. Give this a try, and it's very similar to the example that we just did. And then after you finish that, we'll come back to the last line here. And it says, if a set contains many elements, many elements, it doesn't make sense for us to write all of them out. We can again use the ellipsis to represent the missing elements. Basically, it's these 3 dots right here. We can put that in the middle of the set. Well, and let's take a look. Example 7, it says use the roster method. Write the set containing all even and natural numbers between 99 and 200. So I know I'm using roster method, which is also called the list method. If it's between 99, my first number is 100, and then I have to do even numbers, so 102, 104, 106. But look how much more space I need to write all of them out. I don't need to write every single number. I just put in the ellipsis, the 3 dots there, and then that way I finish it with the last 2 numbers. So I start with the first 2 or 3 numbers in the set, and then I put in the dots in there, the ellipsis in there, and then I finish it with the last 2 so that I know where my set begins, where my set ends, and I know that in the middle it follows the same rule. So give it a try yourself and see if you can finish this one. After that, I want to revisit our learning goals for today. There are 2 learning goals. Do you understand set notation? And in all 3 methods, can you write sets with all 3 methods? And if the answer is yes, that's great. Proceed with your independent practices. If you have question about it, pause the video and approach one of your classmates or raise your hand. I can come and help you. Okay? Thank you, guys. Bye.